So when we talk about the structure of an atom, what you have studied about the structure of an atom consists of a nucleus, and inside the nucleus we have neutrons and protons, and around the nucleus there are particles, electrons are there. So inside the nucleus we have neutron and proton, and around the nucleus we have electrons moving in a region which we call shell or orbit. How we know that, or how we conclude that this is the structure of an atom? So if you recall the Rutherford experiment, which you have studied in IGCSE, so there were observations of the Rutherford experiment and he drew conclusion from those observation. So what he did, he took a metal foil, a thin metal foil, and he targeted this metal foil by the alpha particles. Alpha particles are also known as the helium nuclei or nucleus of the helium. Metal is having a lattice of the positive charges and the delocalized electrons. Here dots are representing the nucleus. So what were the observations of the Rutherford experiment? That when he used alpha particle, what is an alpha particle? Alpha particle, two protons and two neutrons. An alpha particle will not be bigger than an atom. It's a nucleus. So even when I draw the alpha particle, I should also put a dot. Okay, because it's like a nucleus of a helium. So alpha particle are the helium nuclei. What he did when he targeted this metal foil by the alpha particle, he observed most of the alpha particle passes through without changing the direction. Few of them changes the direction. Few of the alpha particle changes the direction, but most of the alpha particle, what he observed passes through. So what is the conclusion he drew from this? Like the first observation was most of the alpha particle passes through. So what was the conclusion he drew from this observation? He said that major portion of atom is empty. That is why, like example, if most of the alpha particle are able to penetrate or a pass, so it means something is empty. Or there's also another conclusion that the size of the nucleus is very small or negligible. So most alpha particle passes through means most part of an atom is empty. Or the second, what we can draw from this, we can also say the nucleus is very small compared to atom. Or the nucleus size is negligible as compared to that of an atom. That was a first observation. The second observation, he observed few of the alpha particles deflected. Like deflected means changes the direction. Why few of the alpha particles deflected? What he conclude, like why they changes the direction? As you can see, this alpha particle here, it changes the direction. Because alpha particle, what is the charge of alpha particle? Alpha particle has two proton and two neutron. Neutron does not carry any charge and proton carry the positive charge. So this alpha particle is positively charged. And we know like charges repel and unlike charges will attract. So if the alpha particle was having a same charge, uh, like opposite charge of the nucleus, then it should be moved towards the nucleus or attracted towards the nucleus. But if it is changing a direction, the alpha particle is deflected and changes a direction, it means it experiences a repulsion. So few of the alpha particle deflected. What he conclude from this, he said that the nucleus contain same charge as an alpha, or nucleus contain positive charge, or nucleus is positively charged. This is the same experiment what you have studied. How did you observe? how he observed the particle, we cannot see the particle, but we can see either a track of the particle or we can see their effect on the screen. So the Rutherford experiment, he was having a fluorescent screen around it. So if this was a metal foil and the screen was all around, so the observation was most part of the other side of the screen was light up because of these alpha particle. As is a fluorescent screen, it glow when a particle hit. Few of them, like few sides were also illuminated because of this alpha particle striking, and very few of the alpha particle bounce back, so that shows a reflection. So he did not see the movement of alpha particle, he only observed the effect on the fluorescent screen of these alpha particle motion. And the third observation was very few of them reflected or deflected at a larger angle. What it give an idea? It's on not only like if something hit a mass or a matter, it will reflect. Like when matter and matter collisions are there, then they changes the direction as well. Like if you are throwing a ball towards the wall, so as a result, what will happen when the ball hits the ball will change the direction. It bounce back. So few of them reflected, it's not only because of the mass, few of them reflected because of the mass and the charge. So these are the observation and the conclusion of the Rutherford experiment. Most of the alpha particle passes through because major portion of atom was empty or the nucleus was very small. Few of the alpha particle were deflected because the nucleus was having a like charges, and very few of the alpha particles are reflected, which shows that there is a matter or a mass is there as well as the charge. Because it's not only because of the mass, it can also be because of the charge, because like charges repel each other. So if the alpha particle is hitting or moving directly towards the nucleus, it will reflected at an angle more than 90. Is it clear? Anyone having a doubt or a question?